So let's start with the shape detection. So shape detection is preliminary step to many things like object detection, object tracking, or semantic or instance segmentation. So without going into much of intro and theory, let's jump into the code directly and understand while going through the codes. So for shape detection, first we are importing the libraries which is required. So CV2 for doing various operations on the images, and matplotlib for plotting the images inside the Jupyter notebook. And then I'm reading the image from my local directory, and this is the image shapes3.jpg, and I'm displaying the figure. So if I run the cell, so as you can see, there are 6 shapes inside, and this is the whole image. Okay. So this is an RGB image. Okay. So what is an RGB image? Basically, you can tell an image as a three-dimensional matrix. So it's an M cross R matrix. So the first two are the pixel intensities, and the third is the channel. So now what is a channel? So in physics, we know that white light consists of 7 colors, right? With your, but computer doesn't understand that, right? So to understand what is a color image, a computer uses 3 channels: the red, green, and blue. So a color image basically is a combination of the 3 channels, or you can say it's an RGB image. So if I just print the shape of the variable image, img dot shape, and I run this, and you can see it's 182, 276, and 3. So 182 and 276 are the pixel intensities, and 3 is the number of channels. So this is the first step, importing the images, and next is converting this image into grayscale. So we are just taking cv2.color function, passing the image here, and using cv2.color bgr to gray, and we are running this. So this is basically a grayscale image. So now what is a grayscale image? Grayscale image basically represents the pixel intensities. So it doesn't have any intensities. So intensities are basically the pixel values ranging from 0 to 255, 0 being the lowest and 255 being the highest. So 0 is basically black in color, and 255 the highest is 1. So you can just remember this by considering these analogies. 0 is basically null, and you don't have anything, so it's black, and 255 is the highest, so you have something, so it's white. So
I can hear, Bhaiya.
Yeah.
Sorry to interrupt, but some people are complaining that the screen is frozen. Can you just reshare the screen? Because the screen is frozen for me too. Yeah.
Okay, sure. So is it coming now?
The screen is not visible anywhere.
Just a second, let me change my network. Is it visible now?
Yes,
That's visible. You can go
Yeah,
on.
cool. Yeah. So I was just explaining the grayscale images. So grayscale images basically the pixel intensities range from 0 to 255. So let me tell you, the grayscale images are not the black and white images. So we have this convention that grayscale images are black and white images, but that's not, because the intensities range from 0 to 255. It's not basically two images, sorry, two intensities, right? So by black and white, we think that it's black or white. But in here, grayscale images, there are numerous colors ranging from 0 to 255. So again, if we see the shape of this, just a second, yeah. Ing dot, sorry, ing gray dot shape, and again I run this. As you can see, there are no channel informations, only the pixel intensities are present. So grayscale images just show the pixel intensity. Okay. So next step would be converting this into a real black and white image. So now how could you do that? For that, the normal thought we have is like setting a cutoff, and above that cutoff, we can set every pixel intensities to the highest value, and below that, every pixel intensity is to the lowest value. So this technique is known as image thresholding. So with this image thresholding, we can get an image which is called a binary image, and this binary image is basically the black and white image. So in here, we do the same thing. We do the threshold to threshold image. We pass the grayscale image. We set the threshold value to 240. So above 240, every pixel intensities would set to the highest value. We pass the highest value also here. So every pixel intensity would get set to 255 above the 240, and below 240, everything would be set to 0. And we also parse the condition, cv2.flash binary, and we run this. Okay. As you can see, so it's totally two color, right? So now you might have a question like, how do we know the cutoff value, right? So for that, it's totally dependent on your picture and trial and error, right? Because every picture depends on every background value also changes, right? Depending on your background, you have to set different cutoffs. So it's not nothing fixed. So like I can show you a live example. So if I just change the value to 200 and again run this, so as you can see, a shape is getting neglected. And if you try to analyze why is it so, and you can see that this is a light image, right? So that's why it's not getting detected and converted to a binary image. So again, if I just continue with this, yeah. So this is how a binary image is formed with the help of thresholding. So I hope that's clear. Now, after we are done with the thresholding, so we can easily see that these are the shapes, and easily we can segregate the background with the shapes. Now, once we are done with this, we can easily determine the boundaries of the shape, right? So without the boundaries, we cannot go ahead with any type of detection. So the boundaries in the technical terms are called contours, okay? So we find the contours next. So for that, we pass the image again, which is the binary image. We select this thing, which is cv2.rtr tree. Now, what is this thing? This finds or retrieves each and every contour points. Now, what are contour points? Contour points are each and every boundary points. Now, in each and every image, we have a boundary, right? So there will be points outside the boundary. So this retrieves each and every boundary points, and this calculates the contours. Now there are two algorithms mainly used for calculating the contours. One is chain approx simple and one is chain approx none. So chain approx simple, this algorithm basically compresses the contour points and doesn't take each and every contour points. So this is basically helpful in lines like straight line or rectangle. So in rectangle, you don't need to take each and every contour points, right? You can just take the endpoints and consider a straight line from it. But in case of circle, in case of ellipse like that, you need to take each and every contour points to make a shape or the boundary. So for that, you need to specify chain approx none. So, and why we're taking none here? Because in this whole image, we have many different shapes, right? So we can't take simple. We have to take none. So now we are detecting the contours here. Okay. So we are done detecting the contours. Now, if we want to see what's inside it, see this contour is an array, right? We cannot pass it with shape. So we need to find the length of it. So if we do len of contours and run it. So we are getting 7, but we have 6 images. So how we are getting 7? So this is because this CV2.final contours detects the whole image as the contour itself. So I think someone is trying to enter. Yeah. So this CV2.contour detects the whole image as a contour, and thus I can see that image is a rectangle, right? So that's the problem with the CV2.contour. So we need to tackle this while detecting the shapes. Now, and again, if we see what's inside the contour variable, we can just print it, right? As you can see that different shapes are getting encoded and these values are there. So what are these values? These values are the XY coordinates of the boundary points. Like in each point we'll have an XY coordinate, right? So these are these coordinates which defines that points. Now let's go ahead with the shape detection. So I will tell why I will initialize this I equals to 0 later. So for each contours, we need to run a for loop because this will go on repeating. So for contour in contours. So as I told you, this contour takes the whole shape as a contour. So we need to ignore the first contour, right? So if it's 0 and I equals to 1, we will continue from the next contour, right? So we are neglecting the first one and going for the second. So from the second, we are calculating the side because shape detection for regular shapes, we need to find the side, and based on the side, we can calculate the shape. So for sides, we are using cv2.approx polydp, and we are passing the contour here. And with the help of this, we are estimating the perimeter. Now cv2.arclength helps in this. Again, we are passing the contour inside it. We are putting true. This true is there because the figure is a closed figure, and I hope it makes sense because every figure is a closed one. Yeah. And again, for this whole approx polydp, we need to pass a true because again the figure is a closed one. So when we calculate this based on the contours and the perimeter and specifying that it's a closed figure, this cv2.approx polydp estimates the sides. Okay. So we have the sides ready. So next is we need to draw the contours outside the boundaries. It doesn't come like that because in this image we don't have any contours, right? And we have that black and yellow like that. We need to draw the contours or the boundaries. Again, we are for that we are using draw contours. We are putting the image. We are specifying the sides. We are putting 0. 0 is basically the scale. We are again putting 000, which is the color of the lines. 0 stands for black, as I told you, and 2 is the thickness of the line. So we have drawn the contours outside the image or the image boundaries to be more specific. Next, we need to put initialize the shape, text, right? So after we have detected the shapes, we need to specify which shape is what, and for that we need to put some text. So if we just randomly allocate text anywhere, and means we don't know which shape will be what, right? We need to put a particular location to allocate the text. So for that, we are using cv2.moments to detect the center of the shape. So this is equivalent to the center of mass in physics, you can say. So this detects the center of the shapes. And if this is there, it helps in aligning the text. Okay. So X and Y coordinates are the centers of the shape. So 30 I have put because the shapes, the text were going outside the shape. So 30 with the help of 30, I'm just bringing it inside. Okay, so we are done initializing the initial parameters. We have the sides, we have drawn the outside boundaries, we have detected the centers of each shape. Now we can go about putting the conditions. So we all know that triangle has 3 sides, right? So if the length of sides is 3, we will put text inside the image as triangle in position XY, which is the center. And this is cv2.font Hershey complex is for formatting the text. So 0.4 is the scale of the text, 000 is the color, which is black again, and 1 is the thickness of the text. So it's done for the triangle. Now, for sides equals to 4, we have two cases, right? For square and for quadrilateral. So how we will specify that? So we know that square has 4 sides same, right? So the first thing is like we are estimating a rectangle around the shapes. So cv2.bound rect estimates a rectangle around the sides. So when we do that, we get the four sides x1, y1, w, and h. So we know that in a square, if we just divide the two adjacent sides, like if we have a square like this, and if we divide this side and this side, we will get one every time, right? Because all sides are same. So we divide this side, float. We are taking float because the number may be in decimal. So we take float W by H. Now we are putting a condition like if aspect ratio is between 0.95 and 1.05. Now why I'm putting this and why not exactly equals to 1? This is because there might be slight error after calculating the aspect ratio. So I'm just giving some range to be sure that the error is handled. So if this is equal to between 0.9 and between 1.05, put text equals to square. Or else if it's not same or it's divided, its value is not between this, put its value is equals to quadrilateral. Okay. Now again, when the number of sides equals to 5, we put the value as pentagon. Number of sides equals to 6, let the value be hexagon. Now I've just coded up to hexagon. Now in case of ellipse, I found that there are many sides detected, but it's not just a regular figure. Okay, so I've just put it if the sides is greater than 6 and in between 15, put the text at ellipse. Okay, and else if all of these conditions are not satisfied, because in a circle it won't be satisfied because a regular side won't be detected in case of circle. So if all these conditions are not satisfied, put the text as a circle. Okay, so I hope this thing is clear, and I run this. So it's run. So and again I plot the figure. So this is the final outcome. So square is detected, quadrilateral is also detected, triangle, circle, ellipse, pentagon. So this is how it detects the shapes, and these are all regular shapes. Now let's change some parameters and try with another image. So let us change the value of the boundary to 1. As you can see, the thickness is quite it's broad, right? I change the value of the thickness, draw contours to 1, and I take another image. Okay, so it's also saved in my local directory, shapes 4, and I press kernel, restart, and run on. Okay. So it will run each and every cell and show my final outcome. See, the boundaries have got diminished, and every image, the shapes have been detected correctly. Now to detect the shapes inside, to display the images inside Jupyter Notebook, I've used Matplotlib. You can achieve the same thing using just one library, that is CV2. So for that, I'm just showing you how. If I just comment out this, the plot one, and open this. And I run this block only. So as you can see, some other window came, and see, this is the detected shapes which came in a separate window. So CV2 doesn't upload the shapes inside the Jupyter node. So with this, you can just use only one library and achieve the desired task. So this is it. This is the shape detection using CV2 and Matplotlib. So this was using regular shapes. So for irregular shapes, the story goes a bit different. So in that, you just detect the contours or the boundaries and do the different other tasks which requires or satisfies your purpose. So that's it. Now I will like to hand over to Jackson and Janvi to go ahead with the Instagram project. Thank you very much.
Janvi, you can share your screen.
Yeah, one second. Okay. Is it visible?
Yes, it's visible. Go on.
Okay, so today Jackson and I would be creating a photo collage for Instagram using Opencv. And also, I hope you guys are active throughout the session because we are going to have a quiz at the end. So let's get started. So we'll import all the necessary libraries. Okay, so we have discussed about all these libraries earlier, except for pandas. So pandas is basically used for manipulating and analyzing data. So that's it. Okay, 1 second. Okay, so now we have all these cartoon images and we'll name it by the position they'll be in the collage. So, for example, center, cv2 dot I'm read, and we'll pass on our image that is center dot jpeg. And okay, so all the images. Okay, so we read all the images from the imread function, and since the images are in BGR by default, so we need to convert them to RGB using the cv2.cvt color function, and we'll pass on our image and then color VGR to RGB. Okay, so yeah, and we are gonna do this for the rest of the 4 images, right? So I'll just paste it. It will be less boring. So yeah, I'll just run it. Okay, so now we'll just plot our images to see how they look before resizing, because later on we are gonna resize all the images. So I'll just quickly plot all the images, and I'll just okay, so let's see how they look. Okay, so you can see that all these images are definitely not of a similar shape. Okay, so this is too big and this is resembling like a rectangle maybe. So these are not of a similar shape. Okay, so but we need them to be in a same shape because we have to fit it in a photo collage, right? So now we'll print images.shape function. My bad. Center is our image, for example, and then similarly for all the images. Okay, so what this does is that images.shape function, it would return us a tuple of the current pixels of our images along with the channels. So let's see. Okay, so you can see that this is 225 by 225 pixels, and this is the channel. 3 is the channel for this image, the center image, this and so on, 575 by 570 and so on. Okay, so now we need to make a photo collage, right? So we need to fit it in a canvas. So we will resize all the images. So we will resize them using the function cv2.resize. We'll pass on our image, and we need to, okay, so I'll compress it by making it 100 by 100 because it was too big. This center image was too big. It was 225 by 225 pixels, so I will just make it 100 by 100. And similarly, I will do the changes for all the other 4 images, and you can you can change the pixels the way you would like the image size for your collage. So I'll just run it. Okay, so now we'll again use our image.shape function to see the current pixels, right? Because we've changed the pixels. So you can see that we have successfully changed the pixels of all our images according to how we wanted them to be. Okay, so now again we'll plot our images. Just copy paste from here. Okay, now you can see that all these images are resembling a same shape, right? So this was a rectangle, this was too big, and now we've compressed it to 100 by 100. So it's a little bit blur also, and this is a square now. So like that. So yeah, so now Jackson would take over and continue with the project. So over to you, Jackson.
Sure. Can you guys see my screen?
Yeah, it's visible.
Okay, fine. Cool. Okay, so we resize the images, and as you can see that the center image is less in size than other images, right? So why is it like that? It is like that because we need it to be in the center, and the center image should be less than all the other images, right? So now a collage is not complete without a canvas, right? A canvas is needed so that you could put photos in that, so that it can be a collage, right? So for that, we'll create a function which will basically create our blank black canvas. The canvas would be black because our photos, the background is white, so it will um, look better. And the parameters in it would be the width and the height of the canvas. And yeah, as I said, our canvas would be simply a black image, and in computer vision, to get a black image, all you have to do is create an array in which every element is 0. Right? So here we would give in the parameters being the height and the width, and the channel, of course, because it's an RGB type image. And then we would use np.uint, which, as I said at the start of the session, it will confirm that every element is an integer, right? And will simply return the image. Okay, so to show you what I mean, I'll create a canvas for the whole collage. So the dimensions of the canvas would obviously be greater than the dimension of the photos, because the canvas needs to be larger than the photos, right? It has to encapsulate all the photos. So I would create an instance of the function, and I would put the dimensions as 430 by 430, as it is greater than 200 by 200. So I'll show you. Yeah, as you can see, it's a black image uh, with the dimensions being 430 by 430. And to show you how we will put the images in this, what I'll do is I'll create a canvas for the center image, and I'll put the center image in that, so that you guys could understand how we are putting the images. So let me create an instance saying canvas for center, and yeah, I would call the function again. And since the dimensions of the center image is 100 by 100, um, our canvas should be just a tad bit greater than that, right? So that it could fit nicely and it could look nice. So I'm just taking the dimensions as 120 by 120, which is 20 pixels more than a center image. And yeah, to show you, both of these images look the same, but the difference is in the scale, right? Here it is going till 120, here it is going till 430, right? So now what we'll do is we have created the canvas. Now we have to insert our image into the canvas, right? So for that, we'll use simple Python indexing, and we would put the coordinates for inserting our image. If you guys are wondering how did we get the coordinates, you could simply take this photo, the center one, and you could open it up in MS Paint, and from there you can get the coordinates. So here I'll put the center image and I'll show you the updated canvas. Okay, my bad, that was a small fault. Okay, as you can see, here's a center image in its own canvas, right? As you can see, it is perfectly placed because it is 20 pixels from the border of the canvas, right? And since we've done this for the center image, now we'll do for the rest of the images, the top left, the top right, bottom left, bottom right. Right. So I'll just do one for the top left photo, and then I'll just copy paste the others because it'll be boring me putting all the values. So here's the coordinates for the top left photo, and I will similarly put the other coordinates, right, for the top right, bottom left, bottom right, and in the end the center photo. And now to show you a final canvas, here you can see that each of our photo is well placed in its respective position, right? Picasso is on the top left and others are there. So this is how your photo collage works in websites like Instagram, Snapchat, Facebook, etc. And this is a pretty cool project because it encapsulates all the things that we have learned in this session and in the last session, right? You could use this project in your portfolio to show that you are well versed with the concepts of photos, images, arrays, CV, etc. And yeah, the code for this project will be shared in the chat box shortly. And yeah, you could give it a try and tell us how it works. Over to you, narrators.
Thank you so much, speakers, for the session, and the all the participants. The code has been shared in the chat box. We have the GitHub repo here. And in case of any doubts, you can put in the chat box, and the speakers will be more than happy to explain the or clarify your doubts. So comment down your doubts on the chat box. Guys, feel free to ask the question
You can
because
put
if
in
your
your
doubts are
doubts.
clear,
Yeah.
it will be easier for the quiz. So do clear them out.
If you guys understood the session, just drop a thumbs up in the chat. How does swap perspective work internally? Basically, it is sort of like array manipulation and it consists of a lot of maths. So yeah, we'll be talking about this in the future sessions. But in real life, you don't really have to understand how it works like very internally because in the end, it's all maths, right? You
So
just have to
what?
understand how to do it.
Yeah.
A lot of thumbs up in the chat. So I guess everyone liked the session, understood it well. That's great. Any more doubts, guys? Feel free to put in the comment box or chat box.
Okay, so I guess we can move on. I don't see any more questions in the chat box.
Yeah.
Okay, so now after the amazing, okay, I guess, no, okay. So after the amazing session by Janvi, Arkanima and Jackson, before we conclude today's session, we have prepared a small quiz to test your understanding of today's topic. The quiz is conducted on the quizzes platform. The link will be shared with all of you in the chat box. You all are requested to log in or sign up on the quizzes platform using your VIT Bhopal email IDs. Please do not use your personal email IDs, as we will be considering the scores and maintaining a leaderboard for which at the end of the sessions we will be giving shoutouts and some interesting prizes. You can only attempt the quiz once with your VIT email ID. There are 5 questions, single answer types. In the quiz, you will get about 20 seconds to answer each of the question. The quicker you understand the question and select the answer, the more points you will get. So for the maximum points, you have to pick the correct answer in the least possible time. I guess the link is shared with all of you in the chat box. So after the session, you can head over to the quiz and attempt the quiz.
Okay, so before leaving, I would request everyone to turn on their camera so that we can take a picture for the session with the speakers. And so everyone comfortable, so please turn on your cameras. We will be taking a quick picture. Okay, guys, everyone just turn on because we can take a photo. Only few of them have turned on. So let's turn on the camera and take a good picture.
Guys, don't feel shy, just turn on your cameras.
Yeah, it's not a normal class, so just be free.
Yeah, I guess we have the screenshot.
Okay. Okay, guys, thank you for turning on the cameras. So before going to the end, one more announcement that if you're creating any projects on the topic of computer vision, so you can upload them using the hashtag CV Week AI Club. So at the end of the event, we will be selecting the best projects and giving them shout out on our social media handles. So create the projects and don't forget to use the hashtag. That will get you a chance to get a shout out and your project will be featured on our social media handles.
Okay,
So
thank you everyone for joining and attending this session. We hope to see you all again with the same energy and enthusiasm in the next session, that is on Friday. Till then, explore this domain more. If you have any questions, you can drop them in the chat box anytime. And stay safe.